Good morning still. My name is Peter Lawrey, and as you mentioned, I have the most answers in the world on Stack Overflow for Java, about 13,000. I've also a Java champion, and I've been developing in IT for 25 years. My company is 5 years old. As you can see, these are the gold badges I have. In some cases, I'm the only one in the world that has that many answers for that particular topic, so in any language. So you can see that's my very technical bent. So what do? We provide a framework for major banks to develop trading systems. We've been running for 5 years. We're self-funded, so that's our background, and we're looking to bring that expertise to blockchain. So the core of our software is open source, and again, the core of the blockchain solution will also be open source Java. It's available on GitHub now. This is all of our software, not the blockchain, but for our main software, we're getting over 50,000 downloads a month on Maven Central. Also, our two key products have over 1,000 stars. So they're very widely used in most banks around the world. So our core technology is based on Lambda architecture, very much designed for pipelining, efficiency. That's very much our focus. And that's what we're looking to bring to blockchain. And also mechanical sympathy, which is really focusing on what is the best way to use the hardware that you have to produce a high-performance trading system. So what do we see as a benchmark? And that's Visa. Visa gets around, can do around 25,000 transactions per second. They actually get about 1,700, but they can take peaks of 25,000. How do Ethereum and Bitcoin compare? Well, not very well, because they're still in the below 10. Obviously, there are other solutions out there that can outperform these two, but we're looking to be much above that. So a single server with just 8 cores in each of the nodes in the cluster can do around 52,000 transactions per second and handle bursts of close to 500,000. So that's without too much investment in hardware. But let's say we do invest in hardware. What could we do? So it's the same software, but with more machines in each node. So you've got more computing power, basically. We can actually do 400,000 transactions per second sustained. To give you an idea, that's actually higher than anyone has a use for. It's more than all the equity trades in the world combined. We'd be able to run through a single subchain. Every subchain can do this, and we have multiple subchain support. So we're looking to regionalize our subchains. So unlike some systems where it's hashed, which means it's completely random as to whether any two people would be in the same chain, and statistically speaking, they just never will be, or almost never will be. We're looking to base it on the ISO 3166 region standard. It's about 4,000 standard regions around the world, every county, state, municipality. So if you're dealing with someone else that's in the same region as you, or the same region as one of your accounts, you will get optimal performance because it's only been transferred within the same subchain. So with multi-chain, we were looking at scaling to in excess of 100 million transactions per second if you have enough machines. So it's really, the key goal is linear scalability. So when in the dot-com boom, the thing that really caused problems with performance was that they didn't have that. They hadn't achieved models for creating linear scalable web services. So that's our stated objective, is to have linear scalability that as you add more machines and more nodes, the whole thing runs faster, not slower, which is one of the downsides of Bitcoin, is that it actually gets slower as you add more machines. So the key operations that we're focusing on are transfer of value and exchange of value, because they are the two most common financial transactions that happen in the world. This gives us the most volume. And microtransactions. In addition, we're looking to support time-locked tokens. These are tokens you can't use until, say, a year from now, but you can buy them now at a discount. So this is a way of making money just by holding value for a period of time. And by asset, I mean not only any fiat currency or digital currency, but any cash asset. So it could be Vodafone shares or S&P 500 token. You can buy and sell those. They can be exchanged for cash. So it's another way of holding and transferring value. You could pay someone in Vodafone shares if you both agreed that was a good idea. What we're looking to do, one of the key things with existing financial institutions is integration. How do we integrate any system that's you bring in to our existing systems? And that's often their biggest pain point. So we're looking to solve that through having a fixed protocol gateway. We have a fixed engine already. And so we're looking to integrate that to this system, which will allow banks to immediately use the technology with a minimum of effort. Another key thing we're looking to add is an AI to manage the volatility of the exchanges. So one of the problems with existing digital currencies is that they have high volatility. In fact, even some fiat currencies have high volatility. And what we're looking to do is have an AI that actively engages in the market if it moves by, say, 3% or 5%. If it doesn't, then it doesn't do anything. It just lets the market do whatever it likes. But if the movement is more than a certain percentage, it starts to buy back or sell off the currency to absorb some of the momentum. And then when it comes back down again, it does the reverse so that it is cash neutral. It's not looking to make any money out of it. It's just looking to be cash neutral, but absorb a lot of the momentum in the market to reduce volatility. And that's about it. Do we have time for quick questions? Yeah. Any questions? So one of the things we're looking to do is to looking to ICO or pre-ICO in the next couple of months. We're not even sure, because we're self-funded, we're not even sure yet whether we will pre-ICO, because we don't really. But anyway, so any questions? Yes.
Where would the AI get its liquidity from to perform these market transactions to stabilize the price?
Okay, so it has two sources of liquidity. One is that it manages, so say for example, you've got the US dollar AI, which manages the US exchange. It has access to the US dollar real banking account. So if you transfer dollars in, it has access to that. So we can use that for buying and selling. It also, part of the coin distribution is that 40% of the coins will actually go to the exchange AIs for managing liquidity volumes. So a very big portion of all the tokens will actually just be there to manage volatility. It won't actually be sold or used for utility. It's just there to absorb these big market movements. Yes.
Right, you're using just blockchain, but you're bringing Java to blockchain. Is that not a step backwards?
Yeah, possibly. Although we've got a lot of experience in doing low latency, high frequency trading systems in Java. We have a tier 1 bank, for example, at the moment. We've built them a DMA, direct market access. It goes through 4 microservices. And end-to-end, the 99th percentile is under 50 microseconds. So from a blockchain point of view, that's unimaginable, because just the verification of a single signature is about 70. So from our perspective, it's only the signing and verifying that really matters from a latency point of view. The actual latency of the core system is very low. And in fact, to get the 400, I can't go back. To get the 400,000 transactions per second through a single thread, the average transaction time needs to be 2.5 microseconds. So that's what we're getting in Java at the moment for the core system, the bit that actually matters, where everything is serialized. So you could perhaps reduce that 2.5 microseconds if you used another language, but the benefit we get from using Java is you've got 10 million developers in Java. So you've got a lot more access to developers who have a variety of skills and variety of interests, not necessarily just focused on, say, being a very strong technical developer. They could also be more from a business background. Yes.
You said your confirmation times are 2.5 microseconds. That's really quick.
Sorry, so the core part of the system that determines the throughput is 2.5 microseconds. But the actual end-to-end, we're looking at 10 millisecond rounds. Is probably gives the highest throughput. We can reduce that, but you end up compromising on throughput. It depends on where that trade-off is. We believe we could go to sub-millisecond, practically, but then you still have to get consensus across many nodes. And it depends on the spec of those nodes, how far they are apart physically, and we're probably talking about a cluster where we've got less control over that sort of thing. We do have support for private chains, and private chains could be much, much faster because it may be run by just one bank and all 5 servers are in the same data center and we can achieve that. But we're trying to work on the more traditional blockchain model where all the nodes can be run by different organizations.
Okay, thank you very much. All right, big round of applause. Thank you very much.